Assalamu alaikum everyone, brace yourself people, because we're about to go to a slide which has 75 set of slides. Sorry, 75 set of slides. I don't know if we can finish this in one video, but I'll be going very quickly because actually theory and this thing of CSH 320, it's rather more memorization than understanding. So if there's a point of understanding, I'll be talking, but if there's a thing that you need to simply note, then you just have to pause the video and note it down, because it's not a good idea to spend time there. So let's get straight to work. The things we're going to do will be covering layering in communication, protocols, standards, and communication layering, addressing, which probably makes no sense to you now. Don't worry, it will make sense. So communication is, like we mentioned in the last lecture, the communication means transfer of data from one medium to another, one entity to another through a transmission medium. That was communication. And data communication is communication through data. So let's not spend time here. So let's just explain this to you. For example, you're going to send something, so consider your data letter. So a letter is written, put in an envelope, you put it in an envelope, and then you drop it to the mailbox. That's ordinary step, the primary step of sending a letter. So until you reach the mailbox, you're still at step 1. Once the letter is carried from the mailbox, it reaches the post office. That's the middle layer. That means it reaches a destination where similar data is handled, letters and handled. Post office doesn't have one letter. Post office handles all the letters. So understand the sequence, how it's working. The thing was very personal at the beginning. Now it's kind of public. That means it reaches the post box, and then the letter is delivered to a carrier by the post office. So the post office gives it to a delivery man, and then the delivery man will get the letter to the receiver. So the layer 1, the layer 3 actually, the layer 3, the thing it did, the sender, the letter was written, it was given an address, it was enveloped so that people can recognize where it's supposed to be sent to, and then it was sent to the mailbox. That was the work of layer 3. And then layer 2, what it did, it took the letter and kept it in a place where all letters are handled, and then it gave it to a delivery man. So managing the letter was the work of layer 2. And then the letter is delivered to a carrier by the post office. And then consider the same layers to the receiver. So the letter is delivered, the letter is carried to the post office of the receiver, and then the letter is picked up by the receiver. So the complete reverse of the process of the sender is done. The yellow one you're seeing is layer 1, the second is layer 2, layer 3. This is exactly how data is controlled. So first the data is set up and it is given an address. That's the first step of sending data. Then the data reaches a place, or a protocol you can say, or a destination where all kinds of data is handled. That's the blue box you see here. Once the protocol that is managing the data receives it, it sends it to a protocol, or you can say a server, or whatever you call it. We'll learn very soon, to deliver the data to a specific address. So that's the idea. Remember this concept, because this is the very basic concept of 320 and how this data communication works, and we are going to be learning in details of this thing. So don't just ignore this. So we have protocols and standards. We already know what protocol is. Protocol is a set of rules, and standards is standards. For example, standards organizations, if they say that okay, this is the standard we approve, then that's a standard, right? So de facto and de jure, the thing you need to focus on over here is de facto and de jure. De facto is the standards that have not been approved by any organized body, but de jure standards are officially recognized. That means they are legalized, they are legislated. So keep up for de jure functions. So the organization which does this standardization, you need to remember this, it's called ISO, International Organization of Standardization. Remember this, don't forget this. And there's this request for comment, RFC, you need to remember this too. So this is a, how can you say this, through this RFC, internet has been developing through recommendation of authorities. So you need to remember this term RFC. And communication process. So there are two types of protocol models. Now we are already going to communication process. So the first type is TCP and IP protocol model, which is de facto. That means it's not legalized, legislated by an organization. However, the OSI reference model is a de jure standard. That means it is legislated by ISO. So we're going to be learning about OSI, Open Systems Interconnection. What's it? Open Systems Interconnections. Remember this. Open Systems Interconnection. That's OSI. There are 7 layers of OSI, starting from layer 1. Now you may ask, can I call application layer 1? No, you cannot. You should not. So, and these colors actually represent the function of those letter. Remember the letter part we described at the beginning of the video, that the delivery man receives it, sends it. This is the work of the layer 2. This is layer 1, where the letter is prepared. In here it reaches the post office, and then here it reaches a carrier who delivers the data. So that's the idea. So the layers are physical, data link, network, transport, session, presentation, application. 7 layers, and the de facto version of this is called TCP IP. We'll look at that too, but not now. So TCP IP model actually includes all these first 3 in a layer called application. You know what, we'll go through TCP very soon, so no need to focus on that now. Look at those protocols over here. Domain name system, this is DNS protocol. Hypertext transfer protocol, you know that very well, it's HTTP. Simple mail transfer protocol, that stands for SMTP. Post office protocol, very famous, it's POP. And dynamic host configuration protocol, that is DHCP. And remember that the first 2 layers are actually implemented in hardware. So the network hardwares do this work, and the rest, including data link, has some work that is implemented in software. You need to remember this very well. These are really basics. So ISO is the organization, OSI is the model. Note it down. Now an easy way to remember this is that all people seem to need data processing. So you have APSTNDP, physical, data link, network, transport, session, presentation, application. So these are the layers. You can memorize it any way you want, it's up to you, but you need to memorize this. That's the primary concern. So you can see this is now the data version of the letter sending. For example, this is where the letter is prepared, and then this is the medium, and then the reverse of this work is done here. That's how exchange occurs. So we'll start with the application layer. Application layer is the interface between human and data networks, and it is responsible for providing services to the user, which is very important. So you know, this is where the Firefox, Chrome, messengers and email comes to action. So this is the really beginning of the place. So you have Facebook, you have web page, you have email, you have Yahoo, Gmail, whatever, you have Viber, you have WhatsApp, Messenger. All these start with application layer. So that's where it begins. Now this is an important, very interesting way. So people create the communication. So you are writing something in the messenger, and then messenger is the software and hardware convert communication to a digital format. So the message is converted to something that the computer will understand, and then it is sent to the presentation layer. Okay, So once the application layer gets your data, it converts it and sends it to the presentation layer. And when the receiver is receiving, the presentation layer prepares the data and sends it back to the application layer. So it's the reverse for the receiver all the time, remember that. And the protocols you will need here, we generally use are DNS, HTTP, SMTP, POP and DHCP like I mentioned. You need to memorize these protocols, and you'll be using these protocols in lab of CSE 320. So, but if you still face problems and you want to know details, let me know in the comments. So presentation layer, okay. So the data was prepared to understandable for computer version, and then it's now in presentation layer, and the presentation layer is responsible for translation, compression and encryption. So this layer will further encrypt the data, it will translate it to a complete binary something, and then it will send this data to the next layer, which is transport layer. But let's start, no, which is the session layer, sorry. So three primary functions for this layer: coding and conversion. So the message you sent, it's first coded and then converted, and then it's compressed, and this is encrypted. So compression means decrease of size and then get it into one place, so one file. So you say you have sent multiple messages, they're compressed to one file, and then the data is encrypted, so it's secured and it's ready for being read by the computer, and that's the idea of encryption. So let's move to session layer. This encrypted data is further sent to the next layer, which is the session layer. Session layer is what its name stands for. Session layer controls the sessions, your first session, your send session. So it is simply responsible for dialog control and synchronization. You don't receive the message after one day, you receive it instantly. That's the work of session layer, you maintaining your sessions. So that's that, nothing to describe here. So you have to note down these works, that to initiate dialogues, keep them active, and to restart sessions if they got disrupted. So your electricity went off and you see that sometimes your browser say, do you want to restore session? That's a work of session layer actually. So these layers are all software related works. So this is why we are still in the area where we're implementing the software. Transport layer, the name tells you what's the work. Transport layer is where the data is transported to where? To network layer. It's a host to host delivery, and so that's the work of network layer. And transport layer is a process to process delivery. So your message is now ready, it's encrypted, it's now ready to go to the receiver. So the transport layer will send this process to the receiver. So the receiver layer will receive this process. So if you want to know it in one sentence, transport layer is responsible for the delivery of a message from one process to another. That's as simple as that. It has some primary functions, you need to memorize this: segmentation and reassembly. That means you will, if you have multiple messages, segment them, and reassembly, there you also have to join them. This is in case of the receiver, of course. Adds port address, very important. Adds port address and sequence number. You need to remember this, note this down, this is very important. Connection control, so keep the connection flowing and keep it under control. Flow and error control, if error happens, control it. Multiplexing, you don't just receive the messenger in your phone. If you have messenger in your PC and in another device, they also receive the message. So multiplexing, that's the idea of multiplexing. The transportation PDU is called segments. Now PDU is packet data unit, so protocol data unit. So this is a protocol, right? So the data unit for this protocol is segments. You need to note this as well, this is very important. And the common protocol used in this layer is TCP. You need to note this as well. When I'm saying you need to note this, these are very, very important. You need to pause this video and write them down or memorize them. So the transport layer basically converts them into segments after receiving it from the session layer, and then it sends it back to the network layer. So the network layer sends the files, and you need to call the transport layer converts it into segments in case of receiving. So this is the full form of PDU, protocol data unit. So then again they have explained it in small parts. So identify and port numbers, like I told you, this is very important, remember this. The transport layer is responsible for adding port numbers, and the port address is a 16-bit port address which is represented as one single number. It's 16-bit in length. That's something you need to remember. Connection control, controlling the connection. So if the traffic is high, then the process will let you know that I cannot receive it right now, so please send it later. So that's connection control. Flow control, if it has too many bufferings, then please send it later, please send less packets, please send more. That's the idea of flow control. And error control, if hey, I didn't receive data 2, where's 2? I received 1 and 3. Data control, error control, that's the work. If you don't understand any of these, I'm going very quickly, please feel free to comment in the section below. I think it's very easy, and like I said, that multiplexing, the same thing happens in different devices. Now network layer. So network, now the slide looks very weird, don't blame me, it's not my slide, it's the academic slide you'll find in TSR. So the network layer is the place where the delivery of individual packets goes from one host to another host. The receiver host, the source host to the destination host, the receiver host. So the PDU for this unit is packets, and then packets are converted to segments if it is being received, and segments are being converted to packets if they are sent. This layer adds logical addressing, which is known as IP address. Very, very, very important. You need to remember this. And the protocol used here is IP as well, Internet Protocol. You need to remember that too. You can see the slide kept them red. So IP address is 32-bit address. It is universal address, each host uniquely defined, and it has 32 bits, and each dot is representing 8 bits. So 4 dots makes 4 into 8, 32 bits. 192.168.1.5 is also an IP address. It can be an IP address actually. So that's the idea of IP address. And data link layer, the second layer. So data link layer receives the packets and then converts them into frame, and it moves the frame from one hop to another. Now we are actually starting the work of the hardware. So here framing happens. That means framing is simply just converting the packets into frames. Transport layer has segments, and you remember that network layer has packets, and now it's frames. So no need to be afraid of what's frame. And there's no fixed protocol for this layer, it varies, so that's good for you. And it also has a work of physical addressing, which is very important. The physical addressing, the physical address of an thing is called the MAC address, MAC address, and MAC address is unique, and the protocol that does this work is known as ASP. So you need to remember this. So flow control, error control, and access control, you have seen this in transport layer, but this is the first step of doing that. So that's that. You need to memorize this stuff. And the MAC address is 48 bits long. So there is a port address, there is an IP address, and now there is a MAC address, media access control, respectively given by transport, network, and data link layer. So these are the things addressing the signal, and then finally it reaches physical layer. In physical layer, it's converted to bits or bytes. Bits is the main thing, individual bits from one hop to another. This is the primary hardware work. There is no software involved here. So as you can see, it's complete hardware, and bits is the unit that works with this. The PDU for this unit, data rate, synchronization, all happens over here. And the topology actually shows up over here. So the topology you learned, physical topology is bus and ring, and the transmission modes, you know, simplex, half duplex, full duplex. We did this in the first slide, right? So you already know what this is. So this is the summary of the OSI layer. So the application layer allows you to access the network resources. The presentation layer translates, encrypts and compresses the data. Session layer maintains the session, it terminates the sessions. Transport layer provides reliable process-to-process message delivery and error recovery. Network layer moves the packets from source to destination to provide inter-network ping. Data link layer organizes the bits into frames to provide hop-to-hop delivery, and the physical layer to transmit bits over a medium. Very core hardware work to provide mechanical and electrical specifications. So that's that. PDUs, encapsulations, you know that. And now we'll be looking at TCP. So these 3 layers of OSI falls into one layer of TCP known as application. Since this is actually the work of application. Transport is different because transport is transport. The network layer is called internet over here because that's the layer where actually the hop-to-hop delivery happens. So this cannot be differentiated. Transport layer cannot be differentiated as well. And the last 2 layers does work of hardware. So that's in TCP it's known as network access model. Remember that this is de facto standard, so this is not legislated. So, but still you need to know the TCP. So data, segment, packet, frame and bits. Remember the PDU form from one to another and the reverse for the receiver. So these are the protocols, you need to memorize them. TCP, ARP, I don't know what I mentioned, but ARP is the protocol that you need to use to maintain MAC addresses. I maybe mentioned ACP or something. ASP, no, not ASP, ARP. Okay, so this is the layer, and internet protocol layer. This is the protocols defined here, here. And these are multiple protocols. So that's the OSI and TCP model. The 4 addresses I mentioned, so the physical address, which is the MAC address, logical address, which is the IP address, port address, which is the 16-bit length address, 32-bit, 48-bit, and the specific addresses, that are the domain name addresses. So I think the video has came to an end with the slide. Come on, how many minutes it's? I don't know. But we just completed 75 slides. Now how's that? So I'll end the video over here. Thank you for watching and happy surviving. All you need to do is survive.